We want to calculate the slope between the points 0, 3 and -2, -2. Then we're going to find the equation of the line in slope-intercept form, standard form, and find the axial intercepts. Don't mind the Fortnite noises in the background. You're probably used to that as white noise anyhow. 0, 3 and -2, -2. First, find the slope. The slope, as we know, is the change in y over the change in x. More conveniently written, or less conveniently, a little more precise, y2 minus y1 over x2 minus x1. Well, if this is our first point, we have an x1 and y1. Our second point, x2, y2. We'll substitute these numbers in for the respective locations. y2 is -2, y1 is 3. That's a subtraction of the 3 from the -2. Then x2 is -2. And then we're going to subtract off 0. -2 minus 3 is -5 over -2, which is 5/2. So our slope is 5/2 at this point. Using the point slope form, we take the slope that we just found and either one of the points, and we'll plug it into this point slope form. Which gives us y minus, we'll use our first point, y minus 3 equals the slope, 5/2, times x minus x1 is 0. So we're just going to distribute the 5/2 to both the terms inside the parentheses, and then we'll set this equal to y. So we have y minus 3 equals 5/2 x minus 5/2 times 0, which is just 0. So we have y minus 3 equals 5/2 x. We can add 3 to both sides, giving us y equals 5/2 x plus 3. It's convenient to write it in slope-intercept form for the ease of graphing. Converting this to standard form. Let's go back. Converting this to standard form, we have our y equals 5/2 x plus 3. We need to do two things. One, clear out all of the fractions. We've got a fraction here. In the standard form, there are no fractions. These are going to be integers. A and B are going to be integers. No room for fractions. To clear out the fractions, we're going to multiply everything by 2, our common denominator. So this whole thing gets multiplied by 2. When we do that, we're going to get 2y equals 5/2 times 2. The 2's are going to cancel each other out, so we're just going to have 5x, 2 times 3 as well, plus 6, because that 2 gets distributed to everything. We're going to multiply both sides by 2. Not quite yet in the form. We need to subtract the 5x over to the other side, so we'll have -5x plus 2y equals 6. This is in standard form. We have integer coefficients, and it is -5x plus 2y equals our constant term 6. From this point, it's easy to find our x and y intercepts, or our axial intercepts, because we're just substituting 0 in for the x and the y. When we put 0 in for x, if we're finding our x-intercept, we're going to actually put 0 in for y, because that's on the x-axis, where y is equal to 0. So when y is equal to 0, it's 2 times 0. Well, that eliminates this term altogether. So we put our fat finger right over that term, because it goes away. It goes to 0. And we have -5x equals 6. A little bit off to the side, we have -5x equals 6. solve for x, x equals negative 6 over 5. That's going to be our axial intercept for the x-axis. So negative 6 over 5, or x equals negative 6 over 5, is our axial intercept. Or we can say that's negative 6/5, comma 0 as a point. The y-intercept, again, we're going to plug 0 in for x, because where the y-axis is where x equals 0, and negative 5 times 0 is 0, so we're going to fat finger that. So we'll have 2y equals 6. Well, little scratch work, 2y equals 6. That gives 2y, divide both sides by 2, 6 over 2, which is 3. So y is 3, and when x is 0, y is 3. So our y-intercept is 0, 3. Let's look at another example. The point 3, negative 2, and negative 5, negative 1. We want to find the slope first. Delta y over delta x, or change in y over the change in x, it gives us, let's say this is our y2, x2, x1, y1 for our first point, second point. So negative 1 minus a negative 2 all over a negative 5 minus 3. This minus a negative, it means that we're adding 2. So negative 1 plus 2 is positive 1. Negative 5 minus 3 is negative 8. It's bad form to have the negative in the denominator, so we'll just move it out front or on the top. So negative 1/8 is our slope. Previously, we used the point slope form to find our equation, the equation of this line. Now we're going to use the slope-intercept form to find that. We still need one point and the slope. We have to find the slope and the b. In order to get the b, the intercept, we need to use one of the points. So we'll just pick one of the points. We'll do 3, negative 2. Negative 2 is the y. The slope is our negative 1/8. X is the corresponding 3. Those are going to be multiplied. And we're looking for b. We don't know what that is, but we have just a bunch of numbers. Along with the b, we just need to isolate the b, get everything else on the other side. Let's simplify this first. Negative 2 equals negative 1/8 times 3. Negative 1 times 3, we pretend this is a fraction, 3 over 1. 1 times 3, and then 8 times 1 when we multiply. We can multiply straight across. So negative 3 over 8 plus b. We want b by itself. We have to get rid of this 3/8, so we're going to add 3/8 to both sides. Well, when we add fractions, we need common denominators. So this needs to be a denominator of 8. In order to do that, this is going to be a negative 16 over 8. Negative 16 over 8 is negative 2. We're just making it have a common denominator. So we're going to add 3/8 to both sides. Add 3/8 equals b. We simplify this. Negative 16 plus 3 is negative 13 over 8. Let's see. Is that right? That looks right enough. Alright, so we have b and we have m. That's enough to plug it into our slope-intercept form, which is y equals the slope, negative 1/8 x plus b, which is a negative 13/8, so minus 13/8. Okay, in order to, we want to write this in standard form. So again, the first step is to multiply everything by the common denominator, which in this case is 8. So we're going to have 8y equals negative 1/8 times 8 is negative 1, so negative 1x. 8 times negative 13 over 8, the 8's are going to cancel, so we just have a negative 13. Add the x to both sides, we'll have x plus 8y equals negative 13. Again, we're adding 1x. I'm not going to write the 1 in front of the x because it's given. So this is our standard form, x plus 8y equals negative 13. The standard form is useful because we can easily find the x and y intercepts. We do this by, again, fat fingering. If I want the x-intercept, I want to know where y is equal to 0. So I'm going to set y equal to 0. That means that term goes away. I'm going to fat finger that. So x equals negative 13. X is negative 13 when y is 0. I want the y-intercept. That's when x is 0. So x goes away, that term. It's fat fingered out, so I have 8y equals negative 13. I'm just going to divide both sides by 8 to get y by itself. So I'm going to have negative 13 over 8 when x is 0. Well, that's a relief because negative 13 over 8 is our starting point, the y-intercept, when we go to graph this in slope-intercept form. And there we have calculated the slope from 2 points, created the equation of the line in slope-intercept form, using both the method of slope-intercept form and the point-slope form in the previous example, converted them both to standard form by multiplying by the common denominator, and then arranging it back into the form of the standard form by really adding or subtracting that x term to the left side, and then using our fat finger method, or substituting 0 in for x and y to find our x and y, our axial intercepts. Thank you. Have a good day.